Okay, we're going to pick back up in the slides. So if you want to go back over to your slides or switch back from the worksheet back to the slides. So we just covered the sales comparison approach. Remember, we said there are 3 different ways to value property, 3 different approaches to value. And the sales comparison approach is the one that we just got done with. And what kind of property are we valuing most likely with the sales comparison approach? Residential and what's the other type? Potentially vacant land, right. Residential and vacant land. Now we want to move along to the second method or approach to valuing property, which is called the cost approach. The cost approach is mostly for insurance purposes. Generally speaking, we don't need to know how much a library is worth. Why not? What are we not going to do with it anytime soon? Sell it. We're not going to market it, so there's no real reason to know how much it's worth unless it burns down or gets knocked down in a hurricane. So we need some type of replacement valuation. Does that make sense for everybody? And so mostly the cost approach is really an insurance question. And it has the least amount of subjectivity about it, but it's also probably the least accurate method, but it's really all we've got, okay? So when we talk about the cost approach, we got 3 steps, okay? Number 1, we're going to value the land as if it's vacant. In other words, value the land separately than the structure. So if you're valuing that library, the first step is just to determine the value of the lot that the library is built on. Pretend it's vacant and value the lot. And the reason we want to value the land separately is because we have a really good method of valuing land. What is that method? What's the first one we talked about? The CMA, or sales comparison approach. Remember, we said it's the best way to value residential property or what? Vacant land. So we're going to use this sales comparison approach to come up with a value for the land. Now, for you, that's in the real world. For you guys on the test, they're just going to give you the land value. They're just going to just straight up tell you what the land value is. So step 1, come up with a land value. Step 2, we want to add the replacement cost of the structure. And we're going to talk about in just a second the difference between replacement cost and reproduction cost. On the test, the math examples are always going to be replacement cost. Replacement cost just means what would it cost to build the same type of structure back in its place. And what do you think? How do you think they're going to give you that for a math question? What do you think they're going to give you as far as replacement cost goes? The size of the building and a cost per what? Cost per square foot. They're going to give you the size of the property, give you a cost per square foot, and then want you to calculate a replacement cost. So far, the math's pretty easy, right? Land value, which they give you, replacement cost. And then step 3, and that's going to be the only little tough wrinkle of doing this kind of math question, is to subtract the depreciation. We have not yet talked about depreciation. So in this section of the class, we learn what the idea of depreciation is, and then how do we actually come up with a value for it. So when we talk about cost approach, you might be asked on the test what the difference is between a replacement cost for something and a reproduction cost for it. Replacement, let me give you an idea of what I mean. Let's say you have a 1957 Chevrolet Bel Air. Is that a nice car? Mm-hmm. Yes. You wreck it. And your insurance company buys you a 2018 Chevrolet Impala in its place. That's replacement cost. What would reproduction cost be? Fix it or replace it with the exact same thing that you had. Which one is going to be more expensive? Reproduction. So when you talk about certain types of properties and whether or not you would use a replacement cost or a reproduction cost, which ones do you think we're going to use a reproduction cost method with?
If it's destroyed?
Well, I could wreck a new car and if I wrecked my brand new car and they gave me another brand new car, replacement cost would be just fine.
If it's destroyed for natural causes?
Not got anything to do with the destruction of natural causes. You haven't Look at the comparison I gave you. I said, if I had a 1957 Chevrolet Bel Air and I wrecked it, I wouldn't want it to be replaced. I would want it to be what? Reproduced. So now, take that same analogy and apply it to real estate. What kind of real estate would you want reproduction of, not replacement of? You want exactly what you had, not the brand new version of that thing. What kind of real estate is that? Historic properties. That's exactly right. Why is that car so valuable? It's a historic car. We would want reproduction value on a piece of property if it was a historic property. If you've got a 200-year-old building and it suffers some damage, we don't want them sticking masonite siding back on that thing. We want the original reproduced. And is that going to be a lot more expensive? Much more expensive. That's the difference between replacement cost and reproduction cost. Now for the math questions, they're always going to be about replacement cost, but you might see a theory question where it wants you to identify the difference between replacement and reproduction. Everybody okay? All right. Now, the square foot method is the way that you're going to have to deal with replacement cost on a test. The square foot method simply gives you the value of a square foot, and you're going to multiply that times the size of the building. So if they say a 4,000 square foot building, that's $100 a square foot, you would just multiply 4,000 times 100, $400,000. That's your replacement cost. Erica, who's over here?
Sorry, guys.
You're fine.
Took a while.
You're fine. Okay? So this is the way all the math questions are going to be. When you talk about the cost approach, you're going to use this replacement cost methodology. There are other more accurate, she lost the top. Catherine's topless, y'all. There are some other more accurate ways of determining replacement costs. They call the unit in place or quantity survey methods. They're almost never used because they're way too detailed. And you would never do them on a test. Now that doesn't mean you should just ignore them for a test. So what should you know? That there are 3 ways to determine replacement cost. What's the most common way? The square foot method. The square foot method. Replacement cost got nothing to do with the CMA. A CMA is the sales comparison approach. We are not talking about the sales comparison approach. We're talking about the cost approach. The most common way of determining replacement value is the square foot method. There are more accurate ways, the quantity survey and the unit in place, but we don't use them very often because with accuracy comes, quite honestly, just being a pain in the ass. Because it's like the quantity survey method, for example. Here's what you would see on a quantity survey method. You need 8,356 man-hours of labor. You need 72,342 pounds of number 10 nails. You need 73,468,000 board feet of lumber. Would that get old in a hurry? Yes. Would it be very accurate though? It would give you a very accurate cost estimate to replace that thing, but it's very hard to deal with. So what you need to know is that by far the most common way of determining replacement cost is that square foot method. Depreciation, which is the third part of this equation. Don't forget, we started with an equation. What was that equation? Step 1 was to do what? No. Get out of that CMA. Get it out of your head. We are not in the sales comparison approach. We have moved to a whole different approach to value. We're in the cost approach. And there's 3 steps in determining the cost valuation of a property. Go back and look at what step 1 was. Determine what? Land value. Land value. That's step 1. You need to circle it. What's step 2? Replacement cost. So land value plus replacement cost. And then finally, minus what? Depreciation. Minus depreciation. So let's talk about what depreciation is. Depreciation is a loss in value. And it doesn't matter what the reason is, it's any loss in value. Now, when you talk about properties that we're dealing with the cost approach, we're not really talking about depreciation from the standpoint of the market went up or the market went down. There is no market for these properties. What kind of properties are we valuing with the cost approach? Special use properties. So we're valuing a library, we're valuing a church, we're valuing a police station. There's no market for those. They're not going to sell. So we're not talking about the kind of depreciation where we lose value because the market went down. We're talking about depreciation because the property itself has declined in value. Why would a property itself decline in value or usefulness? Give me some examples. It's not been improved, so we haven't done any work to it. Well, could we also not do maintenance on it? How about just age in general? Does just age in general lessen the usefulness of a physical structure? All of those are examples of depreciation. And so when we're talking about a cost valuation property, we always make the assumption that it is depreciating at all times. It is always becoming less valuable over time. And here's why I know that. Well, I'm going to go back, and I know you were asleep because I've already seen that based on the questions I've asked thus far in the last 5 minutes. Why did I say we need the cost approach? What was it used for? Insurance purposes. Think about when insurance replaces anything for you. Do they pay you the value of it brand new, or do they pay you a depreciated amount? If you go wreck your car, they're not going to give you the cost of that car brand new. They're going to give you whatever the depreciated value. Does that make sense for everybody? So when we do a cost approach valuation, because this is really centered around insurance, we always have to depreciate these properties. So step 1 is to value the land. Step 2 is to add the replacement cost. And then step 3 is going to be to subtract the depreciation. Now here's one thing you need to remember about depreciation. Land does not depreciate. There's no such thing as depreciation of land. What depreciates? What becomes less useful over time? The structure, the building, the improvements become less valuable over time. The land does not depreciate. Does that make sense for everybody? So now, you need to know the verbiage on this screen. This is prime territory for test question from Chapter 17. The different types of depreciation. Depreciation can come in 2 forms, curable or incurable. Curable doesn't just mean fixable, it means easily fixable. Incurable doesn't mean not fixable. Truthfully, most things that are incurable are fixable. The difference between curable and incurable is cost. How much does it cost? Can you pretty much fix any problem with a structure? Yes, as long as you're willing to do what? As long as you're willing to spend an unlimited amount of money. Does there come a point of no return where the cost of the repair is more than the value of the property? Yes. That's the point where you have an incurable level of depreciation, where the cost to remedy it or fix it exceeds the actual value of the property. Does that make sense for everybody? That's considered incurable. I don't want you to think of incurable as meaning can't be fixed. For example, if you've got a building that its replacement value is $150,000 and it needs $125,000 worth of foundation work, that's probably an incurable level of depreciation. Because even if you spend $125,000, the building's only worth $150,000 at that point. Nobody would make that kind of investment. Does that make sense for everybody? You know, you would probably demolish the building and invest that money in a new building that would have much greater usefulness and value rather than repairing that old one. But if you had that same building that was valued at $125,000 and it needed $10,000 worth of foundation work, would that be a curable deficiency? Is everybody okay with that? That's the difference between curable and incurable. Now we need to talk about this word obsolescence. What does the word obsolete mean?
replaced, been replaced.
Maybe it's been replaced. No longer what? I like no longer. I like that as a start. No longer useful, out of date, right? Says the 22-year-old, out of date. 20, 24. Excuse me. So sorry. I literally have clothes that are your age. So we've got obsolescence.
Yeah, but look, we're all here though. You just got started early.
That's right. You started early. I wish I had started at that age. So when you talk about obsolescence, truthfully, what you're talking about is something that is no longer desirable. That's really what obsolete means. It doesn't mean broken. Things can be working just fine and be obsolete. You know, like for example, we use something in this class every day that's obsolete. This is obsolete. Now, you all use them because you're required to use it by the Real Estate Commission because they won't let you use what? A smartphone. But hasn't a smartphone surpassed the need for this thing? Absolutely it has. This is an obsolete device. Doesn't mean it doesn't work. It still works just fine. But very few people own them any longer because they're no longer desirable. Because they already have in their pocket something else that does not only that, but 65,000 other things too. And so obsolescence in a building works the same way. It doesn't mean the building is breaking down. It doesn't mean anything's wrong with the building. It just means there are certain things about it that are not desirable. So with that in mind, give me some examples of an obsolescence in a property. Something that would make the property seem not desirable. It's summertime. Lack of air conditioning. Lack of air conditioning would certainly be an obsolescence. Does that make sense for everybody? And let's go ahead and label it which one. It's a functional obsolescence. A functional obsolescence means that something is outdated or not currently useful. That's what a functional obsolescence is. So lack of air conditioning is a functional obsolescence. Now, that could be curable or incurable. What's going to determine whether that's a curable or incurable functional obsolescence?
How much it takes to...
How much it takes to put it in there. How much the cost is versus what's the value of the property overall. Does that make sense? Could it be either way? Something like that. Sure. How about bright brass fixtures? Shiny brass. Yeller brass. You know what I'm talking about, right? 1985 bling, right? Is that an obsolescence?
Yes.
Yes, because current buyers do not want it. Well, that's a good example of something that can be functioning just fine. The vast majority of those fixtures work just fine. There's nothing wrong with them. But do they lower the value of the property? Yes, because they're no longer desired. Does that make sense? Now, would that probably be a curable or incurable functional obsolescence? Very curable, because generally the cost of replacing that would be well worth it within the context of the value of the property. That's a curable functional obsolescence. Does that make sense for everybody? How about a 5-bedroom, 1-bathroom house? Is that a functional obsolescence?
Oh my God.
Yes, and that's probably an incurable one. You know, depending on the layout of the house and what room you could take to make another bathroom, that's definitely a functional obsolescence and maybe an incurable one. Economic obsolescences you should pay attention to for test-taking purposes. An economic obsolescence is always incurable. And here's the reason. It's not on the subject property in question. It's around it. It's nearby. It's on somebody else's property. Would a hog farm next door lower the value of your property? That's an economic obsolescence. It's any external factor that lowers the value of a property. That's an economic obsolescence. And it's incurable because you can't what? You can't change it. You can't make it go away. So every property in Briar Creek has an economic obsolescence. The airport. The airport's an economic obsolescence for every single property up there. And because what we know is, even though those are still high-valued properties, they would be even more high valued if they didn't have what? If they didn't have the airport noise going by all the time. Everybody okay on this terminology here? Okay? All right, so make sure you know functional obsolescence versus economic obsolescence for sure. As far as the math of calculating depreciation, when we calculate depreciation, and we're almost, the lecture's very short on the cost approach, we're almost to the point of doing the math on it already. When you calculate depreciation, there's some terminologies you need to know. You need to know something called the effective age, and you need to know something called the economic lifespan. The effective age and the economic life. So I want you to think by economic life. I want you to write down something. I should have put a picture on the slide. I need to do that. I need to remind myself to do that. By economic life, I want you to put down it's a fuel gauge. It's a gas gauge. See, every car has a different size gas tank, right? Don't they? Pretty much. But they all have a fuel gauge. And no matter how big the gas tank is full. Does that make sense for everybody? Buildings work the same way. Every property has its own economic lifespan, but for every property, that economic lifespan is like a gas gauge. And when the property's brand new, when the structure's brand new, guess what the gauge is reading? Full. And when the gauge is reading 0, what do you think is true of the structure? Its value. Dead. It's what? It has no value any longer. That's the economic life of the property, because it's the time that it has economic value. When it's brand new, it has all of its economic value remaining, and as time goes on, what does the gauge do? It goes down. But here's the thing, and this is why I say it's like a gas gauge on your car. Can you move the needle the other direction? If you put gas in the car, you can add back to that lifespan, that fuel range, right? Guess what? You can do the same thing to a property. You can put fuel back in the tank. How do you put fuel back in the tank of a property? Spend money. Doing what on it? Improving it. If you renovate a commercial building, have you not added to its economic lifespan? You've essentially added years back on. So what you've done is you've taken that gauge that may be down to 25%, you've pushed it back up to 75% or 80% by renovating that property. Does that make sense? So I don't want you to think of an economic lifespan as being a certain number of years. It's the number of years that we expect that the property will be useful. Everybody okay with that? Not that it will stay upright. That it will be useful. The effective age is where the needle is at any point in time. Can that change? See, here's the thing. The economic lifespan can't change because full is full on any gauge, right? Half is half, full is full. The economic lifespan, if the economic lifespan is 50 years, what is the economic lifespan always? 50 years. What can change, though, is how far we are into that 50 years. What if the property has an effective age of 30 years and we renovate it? What's it going to do to the effective age? Effective age. You want to add 8 to your age, or you want to take it away?
Decrease.
Which would you rather do? You want to be younger or older? So, let's start again. Let's say the property has an effective age of 30 years and we renovate it. Which way is the effective age going to go?
We renovated it, it's going to go this way.
Down, right?
Right.
It's going to go down. You're going to lose age. It's going to go down. Can you have work done on yourself?
I'll say it's more like Botox, isn't it?
There you go. Can you have work done on yourself? Have you changed your actual age?
No.
Have you changed your effective age? In other words, the way everybody views you,
Yes.
the way you are seen. Yes, that's the whole point of having it done, right? A building works the same way. A building has an economic lifespan, and that is what it is. If it's 75 years, guess what? is 75 years. But it also has an effective age, and that effective age is not based on a certain number of years. It's actually based on a perception. It's based on how old the building looks and feels. So if the building has an effective age of 20 years, that means it looks and feels what? 20 years old. Could it be 80 years old and have an effective age of 20 years? Yes, because we've done what to it? We've upgraded and renovated it. Does that make sense? So understanding that concept will help you so much with depreciation, because depreciation is just a ratio. It's a rate. Think about every rate T-bar we've had. Well, first of all, anytime we have a rate T-bar, the rate's always down here in the bottom right-hand corner, right? So in this case, it would be rate of depreciation. The rate's always down there in the bottom right-hand corner. You got two other things. You got the effective age, and you've got the economic life. When we're calculating a rate, I said it's always the part, the thing you're trying to count, divided by the whole, the total number of something. When you're talking about effective age or economic life, which one is the total? Is the age the total, or is the economic life the total? So the life goes on the bottom. And then what's left to go on top? Right there is your formula for calculating depreciation. That will get you to a depreciation factor. Does that make sense for everybody? In other words, what you're calculating is how much that property has depreciated. Is everybody okay on that? How much has the property depreciated? How long is its economic life? How far into that economic life is it? And then do the division. And that'll give you how much depreciation it's lost. And I've got that on the next slide here. So when you calculate depreciation, it says divide the effective age by the economic life. So for example, let's say a property has an effective age of 70 years. And it's 20 years into that economic, or 20 years into that. It has economic, I'm sorry, I wrote that backwards. My brain is not functioning. I said it right and wrote it backwards. So we've got an economic lifespan of 70 years, and we're 20 years into that. We have an effective age of 20 years. Okay? So the property is expected to be economically useful for how long? For 70 years. And how many of those 70 years have been used up? 20. Do the math. 20 divided by 70. And it's a rate, so what do you always do with a rate? How much depreciation has it had? How much? 28.57% depreciated. Does that make sense? So, if you knew the value of the property, could you multiply that times the value to get the depreciation? Sure. And that's all there is to it. That's all there is to it when it comes to calculating depreciation. So, here's an example. It says a building has a replacement value of $125 per square foot, and it's 2,000 square feet. The building has an economic life of 50 years and an effective age of 15 years. How much has the building depreciated? Well, what they told us is the building has an economic life of how long? 50 years. And what's the effective age?
15.
15 years. So can you do that math? %, right? 15 divided by 50 times 30% gone, right? So that's the way to think of it is, it's 35% gone, or 65% remaining, whichever way you want to look at it. Glass half full, glass half empty. All right? How much was the building worth when it was brand new? What was its value brand new? $125 per square foot for how many square feet? 2,000. So, how much is that building worth brand new? $250,000. Can we not take that $250,000 and drop 30% of it away? Times 30%. Losing 30% depreciation. That's $75,000 in depreciation. Everybody okay with that? 75,000. Remember, that's step 3 of the cost approach. What was step 1 of the cost approach? Value the land. What was step 2? Add to that the what? The replacement value of the building. So, let's just pretend this question was 1. The only thing we're missing here to come up with the value is the land value. Does that make sense? So let's say this lot's $50,000. What's our math going to look like? Step 1, land value. How much is it? $50,000. Plus what? $250,000, because that's the replacement value of the property. And then minus the depreciation, which is what? $75,000. Now notice, I did not add the 50 and 250 together and then do the depreciation. Why did I not do that? What do we say about land and depreciation? Land doesn't depreciate. Land does not depreciate. Land never depreciates. So you're only depreciating what? The structure itself. So it is land value plus replacement cost, and then minus the depreciation of just the structure. So how much is that property worth? What's the cost value of that property? $225. $225,000. That's all there is to it. That's it. That's it. Land value plus replacement cost minus the depreciation of just the structure. All right? So let's do this. Let's go back over to your worksheet.
All I say is just study this.
All right, look at number 14. It says how much depreciation has accumulated on a 40-year-old warehouse which was built with a replacement value of $750,000 if the building has an estimated economic life of 60 years and an effective age of 28 years. What are they asking us for here? What do they want to know? How much depreciation? Right there. Okay? So, we know that depreciation, the T-bar formula, looks like this. On the top, we've got the effective age, not the actual age, but the effective age. In this case, it doesn't matter, they didn't give us both. Okay? Over the economic life, right? And that will give us the percent depreciated, or the rate of depreciation. All right? Talk to me. What is my effective age in this thing? 28 years, right?
Yes.
And what is my economic life? 60 years. Can we do that math? 28 divided by 60? And it's a rate, so we multiply it times 100, right? What rate of depreciation do we have here? 46.67% depreciated. Is everybody okay on that so far? And what was the value of it before it started depreciating? So it started at 750 times 46.67%, and that'll give us our depreciation. $350,000-ish. Around.
666.
Yeah, right. If you leave it in that, you probably get 350 even, most likely.
Of course, I had to go to one.
Everybody see where this number comes from? Okay? All right? Because if you can do depreciation, you can certainly do an actual cost problem. So look at number 15. One of these or just two? Okay. Let's do number 15 together. It says the worship facility is being valued for the purposes of determining the cost of insuring the facility. The building is located on a lot that is valued at $96,000, contains 4,200 square feet of usable area, and is 15 years into an expected economic life of 50 years. Using this information, and knowing that the cost of replacing the structure itself based on local building costs is currently $110 per square foot, what's the estimate of value for this property using the replacement square foot method of the cost approach? All right, talk to me about the 3 steps. What are they? Step 1.
Land.
Determine value of land.
Number 1, land. Plus what? Plus number 2, replacement. And then minus what?
Depreciation.
Minus number 3, depreciation. All right, that gives us our roadmap. Let's start working on it. We know the land value. How much is that? $96,000. No math involved. We like that. Now, as far as replacement costs, they tell us the building is 4,200 square feet, and how much is each square foot worth? 110. So that's just going to be 4,200 times 110. $462,000 plus 462. Now don't do that math yet, because we need to subtract the depreciation. Remember, depreciation only applies to what? The replacement value of the structure, not the land. So we're only depreciating this number. Does that make sense to everybody? We're only depreciating the replacement cost. So, depreciation, here's what we know about it. Our T-bar formula looks like this. We've got the effective age on top, the economic life on the bottom, and then our rate of depreciation. Okay? So, they told us that the effective age is what? Effective age is how long? 15 years. Okay? And then what's our economic lifespan? 15 over 50.
Yep.
And if we do that math, 15 divided by 50 times 100, because we're calculating the rate, that's 30% depreciation, looks like to me. Does that sound about right? 30%. 30% of what number? 462, right? So, $462,000 times 30%, and that's going to be minus $138,600. And then it's just a matter of totaling that up. Does that make sense for everybody? So it's $96,000 plus $462,000 419, 400? Again, just make sure you follow those 3 steps. Land value, plus replacement cost, and then minus the depreciation just of the structure. Alright, I want you guys to do the next one. We're going to take a few minutes and work on the next one. And if you get it right, I have
We finally get to eat our food.
Papusa's reward for you. You don't have anything to say? Uh-huh. Make a difference, right?
Yeah.
Good.
That's what's around that.
No, that's fine. You're
Is
good.
that right?
That's good.
Okay.
Perfect. You'll be right. I should do that.
Okay.
Yes, I did. You're good. 472, 150. All right, let's go ahead and take your break and have your papusa snack. Ain't you waiting long enough? See what a great motivating factor it was? You all got it right.